Moving along now in our discussion of natural gas, the logistics and value chain. Now that we have gathered and processed the natural gas, it's ready to be shipped to market using natural gas transmission pipelines. Now these are going to be large diameter pipes. Okay, this is steel pipe. These days you'll find a minimum of probably 16 inches, all the way up to 42-inch pipelines. And the primary function of transmission pipelines is to connect the supply areas to the market areas. As we mentioned with the wellhead and using compressors to boost the pressure of the wells to meet the downstream pipeline pressure, we have to push this gas now in a transmission pipeline from those points of receipt of the wellheads all the way to the marketplaces. And in some cases we're talking about pipelines that originate in South Texas and run all the way up to New York City. So again, you can imagine you've got compressors all along the way continuing to boost the pressure up. We say that the gas flows to the point of least resistance. That just means that on the consuming end, as the gas is being burnt at the various end users, then other gas has to replace it. And so the pressure is lower on that end. The higher pressure pushes that. Here's just some pictures of the process of actually building transmission pipelines. You can see in the upper left, that's the right-of-way that's being dug out, and then all the steel pipe, the steel tubing is laid in place. In the middle picture, you can see where they're actually having to come up over a bend of a mountain there. And then these sections get welded together, and in the lower right you can see this is a specific type of equipment that lifts the pipe up once it's been welded and lays it into the trenches. When all said and done, this is what you see. So if you ever see pipeline right away, all you'll see are these above ground valves. Everything else is buried. Now here's a pipeline company in the state of Oklahoma, and I like to use this diagram only because if you look, you can kind of see the red pipes are the transmission systems, and all the yellow are the spidering types of gathering lines. So you have all these various gathering lines of various wells coming to the yellow squares, which are the processing plants, and in turn, once processed and cleaned up, the gas goes to these transmission pipelines. Terminology wise, we talk about receipts. Any source of natural gas that is received into the transmission pipeline is known as a receipt. Now these can be wells that are flowing directly in. These can be what we call CDPs, or central delivery points. Again, getting back to the diagram of the multiple wells coming to a common point, and then they can come into the transmission pipelines. Processing plants, what we call the residue lines, the gas that leaves the processing plant once it's been stripped of natural gas liquids and it's been cleaned and now meets the quality standards of the downstream transmission pipeline. It comes in that way. Pipeline interconnects. The pipelines crisscross each other in a lot of places throughout the country, and that provides for one pipe to send gas to another pipe. And so anytime we have that gas moving from one pipe to another, then the downstream pipe receiving the gas from the upstream pipe, that upstream pipe is then a receipt point. And then of course storage facilities. When we put gas in the ground for emergency or peaking purposes, when we draw it out, the gas is then received from the storage facility to the downstream transmission pipeline. And then on the flip side, the deliveries, one of the most common deliveries is to a local distribution company, or just your common gas company at what's known as the city gate. And that's where the gas company receives the gas and then distributes it to its various end users. We also have direct connect end users. Power plants, fertilizer plants, and other industrial and commercial customers like that may be tied directly to the pipeline as opposed to having a gas company serve them. And again, the flip side of what I was talking about with interconnecting pipelines, one pipeline can in fact deliver gas to another pipeline. And then storage facilities. In order to fill a storage facility up, we have to take gas off of one pipeline and put it into the ground. Transmission systems, because these are, gas is flowing 24/7, 365 days a year. The pipelines have to monitor that activity. And so this full integrated electronic system we refer to as SCADA, that is supervisory control and data acquisition. It's the electronic transmittal of pipeline data to a central monitoring and control center. They're looking at the pressures and flows, pipeline pressures and the amount of actual volume of gas flowing throughout their system. As I mentioned, it's monitored 24 hours a day. But the control part comes in where they actually have control of the pipeline facilities. They can start and stop compressors, they can open up and close valves, and they also can control what are known as regulators. The regulators can control the volume of the gas or the pressure of the gas on the system. This is what a typical gas control center might look like. Again, these are manned 24/7, and they're keeping an eye on the pressures and flows throughout their system. Now here's a simplified map of what the North American natural gas pipeline grid would look like. The sort of shaded areas represent large producing basins, and again, the idea being that transmission pipelines have initially been set up to move gas from these various supply basins to the consuming regions. Now here's the traditional flow, again coming from major basins to other areas, and you can see traditionally pipelines were bringing gas to the Northeast, but that has changed in recent years, and the reason it's changed is because of the shale plays. Again, looking in the Northeast at the Marcellus and the Utica, there is a considerable amount of gas coming out of the Marcellus these days. Well, if there's gas being produced right there in the Northeast, then supplies coming from other regions are being backed up. Here were some of the original projects due to move gas from, as believe it or not, as far back as the Rocky Mountains all the way to the Northeast. And then the initial production coming from the Marcellus, get it over to the Northeast markets as well. And now there are, as you can see, quite a few projects. Some are trying to move the Marcellus gas still towards the east, especially New England, but others are actually going to be moving gas out of the Marcellus and Utica shales to the southeast part of the United States and back to the western part of the United States. Here are some of the projects that are specific to the Marcellus, again moving gas to the east or moving gas to the southeast down the Atlantic seaboard to two of what will be eventually LNG export facilities. And still, New England is pretty much starved for gas, so some of the gas is trying to get over there. There are expansion projects that you see over here in the lower right, because prices in Boston and New England for natural gas in the wintertime are absolutely astronomical, and it's because they do not have a lot of access to the regional supplies. So there will be pipeline expansion projects to help alleviate this problem in the coming years. And as I kind of mentioned, some of this Marcellus and Utica shale gas is going to move back west. They actually have a surplus. They're producing more than the Northeast is currently using. And here's just an example. This is Energy Transfer Partners out of Dallas. They've got a planned project to bring Marcellus and Utica shale gas back across to what is known as the Panhandle Eastern Pipeline Company, or PEPL, to help serve their markets up in the upper Michigan and over even into parts of Ontario. Some more westbound projects. American Natural Resources, or ANR, is owned by TransCanada Pipelines, and you can see here they've got projects to move gas west out of the Marcellus and Utica shales as well. Here again are some specific northeast to southeast pipeline projects. There's supposed to be economic growth in the southeastern part of the United States, and so there's expected increase in demand there. So some of this Marcellus gas is going to try and get in that direction. And as I mentioned before, there are two LNG import facilities along the Atlantic seaboard. One is Cove Point, Maryland, and the other is Elba Island, Georgia. Now, it's highly likely that these will become natural gas export points, so there are some pipeline projects in the works to get gas from the Marcellus down to those facilities. These are just some of the key cash points. We talked about the cash marketplace before. You have seen on the Natural Gas Intelligence website where ICE daily cash prices are posted. These are some of the key cash market points up in the Marcellus and Utica region. Now, These are just some pictures of what can happen if the pipeline is not monitored properly. This was actually a pipeline that burst. It was the El Paso pipeline, which runs from West Texas all the way to California. This unfortunately occurred in a national park in Arizona, and it literally, as you can see, blew a crater out. At the time they took these pictures, I'm assuming these were the first people on the scene, the safety people with the pipeline company. You can see there's still methane in there that's burning. This is the cutaway of the side part of the pipe. Now, it blew out exactly where it was welded together. There were a combination of things that had happened here. Obviously, this part of the line had not been inspected on a regular enough basis to, in fact, determine that there was some type of a defect in the pipe. The other thing that more than likely happened was that the pipe was overpressured. That, in fact, it was running at a much higher pressure than was safe for this particular segment. And then there had to be some type of ignition source there, because once the pressure of the pipeline erupted the pipeline, something had to ignite the natural gas. Unfortunately, you can see this entire area has been scorched by the fire that came from this particular rupture. Here's a piece of the pipe. This is part of the pipe that's missing. First of all, two things. If you look back here, you don't see any snow whatsoever. This whole scorched area within the right-of-way, and then yet off to the side somewhere, you see snow on the ground and literally pieces of the pipe that were blown over into the woods. This is a section of pipe, again, that blew out of there. Now, when the pipe is actually made, it's made from sheets of steel, and it's rolled, and then there is a weld that runs along laterally, and that's where we get the rolled piping or the rolled steel. So you can see this explosion was enough to rip an entire section out of the ground and rip it along its initial weld.